So, today's objective, I can solve real-world problems using systems of linear equations. Let's read it together. 1, 2, 3. I can solve real-world problems using systems of linear equations. So, today we get to the point where we start applying what we already did. We already know how to solve it 3 different ways. Today we're going to be looking at word problems, your favorites. All right, here we go. So I gave you guys the Cornell notes, so get those in front of you. And we already know what systems of equations are, so therefore we don't need a Freyer model. But I do want to go over the problem-solving strategy steps, okay? So, problem-solving strategies. Let's circle stuff. I want you to circle the word read for the first step in red. Read. And underline at least twice. I want you to double underline the word underline and circle the words key information. Step 2, use a table, and I want you to circle the word choose variables. So use a table and choose variables. Step 3, reread the problem, and I want you to circle the word write and underline expressions and equations. Step 4, solve the equations, and at the end, check. So now the process is very simple. It's a little lengthy, but it's very simple if you follow the steps. And check this out. And this is the process that you should take for any word problem that you do from this point forward, okay? Including the time that you leave high school. Make sure in college you remember this process because you're going to need it. So let's see. Read the problem at least twice. Some of you, sometimes you just read it once, and you're like, oh, I can't do it. No. Yeah, I know. I can totally picture you guys eating your hot Cheetos. Oh, I can't do this. So make sure you read it at least twice. As you're reading it the second time, you need to underline key information. Underline and circle key information. Step 2, use a table to organize your information once you circle stuff. Once you organize it, make sure you label things with variables. Start putting variables to different information. Step 3, reread the problem, and then from the information, you're going to write expressions or equations. Okay? At the end, once you have equations, you're going to be solving those equations, and then you check your work. All right? So let's go into straight to a problem. Here we go. Example 1. Oh, sorry. Here you go. Example 1, it says, Paige has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents a sheet, and the cardstock costs 75 cents a sheet. How many sheets of each can Paige buy? So, here it goes. Let's go back and read it again. Paige has $7.75. So here they're talking about money. I'm going to box this because that's key information, $7.75. And now that I started boxing money amounts, do you see any other money amounts? Yeah, the 50 cents. Box that one, and also box the 75 cents. Okay? Now let me continue reading. Paige has $7.75 to buy 12 sheets. I think that's important. So with blue, I'm going to box 12 sheets. What kind of sheets? Felt. So box the word felt. And for those of you that don't know what felt is, it looks kind of like a foamy cloth that they use to make, it's kind of like foam. And you can cut it and you can make designs out of it. Who's seen those flowers that they sell like for scrapbooks that it kind of looks like foam, but it's not really foam? They have different kinds. They sell that at the dollar store. That's felt. And the other kind is cardstock. Who's seen cardstock? Cardstock is kind of like construction paper, you know, the ones that you used to use in elementary, those long ones, different color, but thicker. They're thick. They're almost kind of like a wood type of hard type of card. Okay? So let's see what we got. 775, 50, and 75. The other information is 12 sheets of felt and cardstock. And she needs that, let's see, for her scrapbook. And underline the question. What are they asking? How many, with green, how many sheets can Paige buy of each? So that's what we need to answer at the end. Okay? So, at the beginning of the year, when we were in one variable equations, I gave you some problems and we did some guess and check tables. And I said, we're going to come back to those. So here we are. Let's build one. Let me remind you. You draw 3 lines down, 1, 2, 3, and 1 across. Everybody got it?
Yes.
All right, here we go. So let's start filling information with what we wrote. First of all, what was the first information that we boxed? And all that is known as money, or in other words, the problem is talking about how much it's going to what? Cost. So this is cost. Cost. What is the second type of information that we boxed? The different items that she was looking at, right? So here, for the second part, we're just going to write item type. Because this is a problem involving sheets of cardstock and felt. But what if they start something similar and it says, she buys 12 fruits. Some are apples and some are oranges. Does that make sense? So the second line right here will be for the item type that the person is buying or selling. So here we go. So let's start with this, the item type. What kind of items is she going to buy? Cardstock. What was the first one that she mentioned? Felt. So what variable could you write here instead of the word? So this is F. So what other item type? And what variable can we use? C. And if she buys a combination of those two, what is the total amount? No, the total amount of sheets. 12, right here. So check this out. So we wrote the variable for felt, the variable for cardstock, and over here was the total amount for the items, right? So let's label that up here. This is for felt. This is for cardstock. And this is the total. All right, so now let's go with the cost. What is the cost for felt? Let's see. The felt cost 50 cents. So we're going to write 0.50. 0.50. And what variable did we use? F. Okay. And what is the cost of the cardstock? 0.75 C. And what is the total amount for the cost? The total amount cost $7.75 that she's going to spend for those. So if the total is $7.75, that means that she needs to add whatever amount of felt for the whatever amount of stock. So this is going to have a little plus here, and the total should be an equal. Is that correct? Same thing with item types. She's going to buy certain sheets of felt, and then she's going to add that to certain sheets of cardstock, and that's going to give us what? 12 sheets. So let's look at our problem-solving steps. Let's see where we're at. Did we read the problem at least twice? Yes. And circle and underline? Yes. Use a table to organize information in variables? Yes. Read the problem again and wrote expressions or equations? Yes. Now we need to do what? Solve and check. All right? So let's go back to the problem. Do you guys see the equations already? If you don't see them, let me write them right underneath so you can see them. Check this out. The first one I'm going to write in red. This one. 0.50F plus 0.75C equals 7.75. That was the first one, so what is my second one? F plus C equals 12. Now do you see them? And what is it called when we have two or more linear equations of the same kind of variable? A system of equations. Do we have a system now? Can we solve this system? Yes. Now think about it. What would be the easiest method to solve this system? Think about it. Think about it. What would be the easiest method to solve this system of equations? Okay. How about elimination?
Yes.
Because they're both already in what? Standard form, aren't they? So check this out. I'm gonna, since I don't have any opposites like positive and negatives here, I'm gonna get rid of the F. To get rid of the F, if this one is a positive 0.50, what does this have to be? That means I need to multiply this entire equation times negative 0.50. Because I'm going to eliminate the S, and this one has to be the opposite, isn't it? So therefore, negative 0.50F, negative times a positive, that's negative 0.50C equals negative 12 times 0.50, that is 6. And if you don't see it, just multiply 12 times 50, and you get 60. Now we can eliminate. Okay, let's do that together. So 50 minus 50, these cancel. Let's continue. What's 0.75C minus 0.50C? 0.25C equals $7.75 minus 6. That leaves us $1.75. Okay? And let's see. Are we already done solving? What's my last step? Divide by 0.25. Divide by 0.25. So C is equal to, how many times does a quarter fit into 175? 7 times. And now to solve for the second variable, I'm going to write my first, this one right here, the ones with the items. I'm going to write it over here. F plus C equals 12. Because this is telling me there's how many cardstock? 7. So if I substitute that in here, that's going to tell me how many felts I need. So F plus 7 equals 12. Subtract 7, subtract 7. F equals 5. So what does this mean? That we have how many felt? And 7 cardstock. So if we write it as a coordinate, this will be 5, 7. So now let's go back again and read it again so that we know that we answer the question. Let's see, what is the question? Paige has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet, cardstock 75 cents per sheet. How many sheets of each can Paige buy? Think about it. What is your statement at the end to answer that question? Think about it. Okay, share your statement with your neighbor. What is your statement? Okay, let's see. Somebody said Paige can buy 5 felt sheets and 7 cardstock sheets with $7.75. 10Q. All right, here we go. So, here we look up. So, let's go through our steps. Did we read it twice? Yes, and circle stuff. Did we build an input-output table to get organized and label it with variables? Yes. Did we reread it and write equations? Yes. Did we solve the equations? And what is the last step? Check. So in order to find out if this is true, do we have a cost? Yes, which is right here. So check this out. I'm going to write the red equation, which is the cost, to see if it's going to come out to that amount. 0.50F plus 0.75C equals 7.75. So let's see. F is what? 5. And the other one is cardstock, which is 7. And I bring everything else down. 0.50 times 5 plus 0.75 times 7 equals 7.75. So let's see. 5 times 50 cents, that's what? 250 plus 7 times 7, 75 cents. Let's see, 7 times 5, that's 35. We got 3. 7 times 7, that's 49. Plus 3, that's 52. Equals to 7.75. $2.50 plus $5.25. How much is that? $7.75. And yeah, that's exactly what she wanted to spend. Boom. Questions, comments with this process? Fairly simple? Yeah. Yeah, it's extensive work, but it's fairly simple since we already know how to do the other parts. All right, so copy this next example in the back. Actually, you have it. Let me turn to that problem. All right, here we go. Next example. This should have been, everybody look up, please. This should have been example 2, even though it says example 3. Okay? Here we go. I'm just going to leave it like that because you already have it like that. Let's read it together. Here we go. With a tailwind, an airplane makes a 900-mile trip in 2.25 hours. On the return trip, the plane flies against the wind and makes the trip in 3 hours. What is the plane speed and what is the wind speed? So that's, I read it once. So let me do that again, and now I'm going to start circling and underlining stuff. So let's see. With a tailwind, that's important information. So I want you to box with red, tailwind. Tailwind. With a tailwind, an airplane makes a 900-mile trip. How long was that trip with a tailwind? 2.25 hours. Okay? All right? And they say on the return trip, so that's the first trip. The return trip I'm going to do in blue. The return trips, the plane flies against the wind. So box where it says against the wind. And it makes the trip in how many hours? 3 hours. And what was the distance for that? It's still the same, right? Because it's the return trip. So I'm going to still box this with a different one. So like that, I know that I need that for both trips. Okay? Then it says, what is the plane speed and what is the wind speed? Okay, so we're done with the information. Now let's underline our question with green. What is the plane speed? So they're asking number 1 for the plane speed. And what is the second question? What is the wind speed? Okay? Now, this is a little different from the previous one. Do you guys notice? Slightly different. Here, let me show you the previous one. On the previous one, there's nothing about miles per hour or distances. Do you notice that? This is a problem that deals with items. So whenever you get to problems that are word problems that involve systems, they're going to be talking about fruit, oranges, and apples. They might be talking about a trail mix that has different type of dry fruit, such as raisins and dates. They might be talking about today there's going to be a basketball game. There's so many boys and girls in a gym. Does that make sense? So this will be an itemized type of problem. However, the problem that we're looking at right now is known as a rate problem. So write that down, rate problem. At the top of that problem, I want you to write rate problem. And at the beginning of the year, when we did a couple of rate problems, I said, remember the formula DIRT? And I said, we're going to be using that later on, okay? So therefore, let's get started. So we already did step 1. We reread it twice. We circled and underlined information. Step 2, we need to build a table. So here we go. 1, 2, 3, and 1 across. Do you notice that it's exactly the same table? Yes. Okay? So now, for these rate problems, we're going to write here at the top, you're going to write, let's see, it's rate times time equals distance. Why didn't I write it the other way around? Distance equals rate times time. Because look at the setup for this previous one. What was at the end? Wasn't the end equal to a total? That's why this one we need to have it equal to the distance. Does that make sense? All right, so let's go back, and with red, let's go over the first information. What is the first information that we boxed? Tailwind. So I'm going to write that right here. Tailwind. Whoa. Tailwind. All right. The second information that I wrote in blue was against the wind. Against wind. All right, so let's see. What was the distance for the tailwind and against the wind? Was it the same amount?
No.
The distance?
Yes.
Yes, so I'm going to write here 900. And for tailwind, 900. So far, so good? What's the time for the tailwind? How long did it take? 2.25. And for against the wind? 3 hours. Okay, I'm not even going to write the H because we just need the time. All right, 3. All right. So now this is where it gets interesting here for the rate. They're talking about 2 different rates, aren't they, at the end? What are the rates that they want? The one for the what? The plane, and the one for the wind. So what kind of variables could I use for those? P and W. So now check this out. What do we write there if it's the rate? Check this out. I mean, I know it doesn't happen here at school that your teachers have you run in the wind. Okay, but what if your teachers made you run during PE in a windy day? What happens when you have the wind hit you on your back? Does it help you with running faster? Well, guess what? A tailwind, that's what it means, because the wind hits you on the tail. That's why it's called tailwind. The tailwind actually increases your speed. So check this out. So this is known as a plus. If it increases your speed, it's a plus. What rates are we talking about? The plane and the wind. Okay? So when you run against the wind, does that slow you? Yeah, right? So that's a negative. So therefore, this is P minus W. Are we there so far? So now that we have our information, now let's write equations. Here we go. Our formula here says rate times time equals distance. So let's use this information for the tail. What is the rate? P plus W. I'm going to write P plus W times time. What is the time? 2.25. To indicate the time, I'm going to open up a parentheses. 2.25 equals 900. I'm going to do the same for the second one. What is my rate? P minus W times 3 equals 900. Bless you. So far, so good? Okay, I'm going to go this way because I want to have a system of equations, which means I need to get rid of that parentheses for both. I'm going to distribute first for the red one. If we multiply, really? If I multiply 2.25, distribute this into each of these, so I get, oh wow. Anyways, sorry. Give me a second. Let me rewrite this really quick. All right, so here we go. So this is P plus W times 2.25. Let's distribute this. This becomes 2.25P plus 2.25W equals 900. Does everyone understand where we got that from? Okay, now let's distribute this one. 3P minus 3W equals 900. Okay, now I can solve this one. If you look at it, do we have a system of equations right here? Is it in standard form? Yes. I can solve it by making these opposite numbers. However, that's going to take me to multiply this times a decimal and multiply this one times another number. That's too much stuff. What I'm going to do better, I'm going to solve this bottom one for P and use substitution to solve this system. So here we go. To solve for P this one, what do I need to do? Add 3W, add 3W to each side. We're left with 3P equals 3W minus plus 900. Plus 900. What's my last step? Divide by 3, divide by 3. P is equal to 3 divided by 3, that's 1W, plus 900 divided by 3, that's 300. Okay? So now, do we know what P is? W plus 300. So over here on the first equation, instead of writing P, what are we going to write? W plus 300. So I'm going to rewrite this one over here. Check this out. 2.25, and instead of P, I'm going to open up a parenthesis, and I'm going to write W plus 300. What's after that? Plus 2.25W equals 900. Let's solve it. What do we do after that? Distribute. This is 2.25W plus 300 times 2.25. Let's see. 2.25 times 300. That is 0, 0. 15. I got 1, 6, 7. That's 6. 2 decimal places. So this is 675 plus 2.25W equals 900. Can we combine like terms? Yes, combine like terms. This is 2.25 plus 2.25, that's 4.5W plus 675 equals 900. At the end, we subtract 675 from each side. We're left with 4.5W equals 225. And what's our last step? Divide by 4.5, divide by 4.5. W equals, let's see, 225 divided by 4.5. We move that over once, add a 0. Let's see, 45 fits into 225 how many times? Very good. Is it 5? Okay, how about 4? All right, 5, I guess. So this is 525, that's 225, 0 and 0. So therefore, what is the rate of the wind? 50. So now check this out. If I was to substitute this into this one right here, it'll give me the rate of the plane, right? So I'm going to write this one right here. P equals W plus 300. So what is W? What is W? 50.
Plus 300.
So the plane speed is 350 miles an hour. So all you have to do here, you write your statement and you're done. So for homework, we're looking at page what? 369, 360, numbers, what is it? 1, 4, 7, 7 through 10, 16 and 17. Turn in your homework on your way out, please. Enjoy your homework. See you guys tomorrow.